Hello everyone and welcome to my video. This is Professor Capko and today we're going to talk about calculating compound interest. Now if you recall in an earlier video we had calculated interest on $1,000 paying 3% simple interest for 5 years. In this video we're going to do similar numbers, exactly the same numbers, the $1,000 in an account, and it's going to pay 3% interest, but it's going to be compounded monthly. We're going to leave it in there for 5 years. So that way we can compare how much difference there is between the simple interest and the compound interest. This will work either way. This will be as if you're putting money into an account or an investment and it's paying you, or if you have borrowed money and you're paying money including interest back to your lender. So the calculation is going to be the same. It just matters whether the money's going into your pocket or into the lender's pocket. And so we're going to continue from there. If this type of content is helpful to you, please smash the like button. It helps with the YouTube algorithm. And I'd really appreciate it if you would subscribe. The more subscribers we have, the more YouTube will push this content out to everyone who needs this kind of help. A lot of folks are learning things online or they're in online classes and they may not get the support that they need. And this is the type of content that I'm hoping to produce to help people with their classes or with their everyday life. So, having said that, let's go ahead and take a look at this. And we're going to look at the numbers. $1,000 is going to be in an account. And let's get the formula for compound interest. And the formula for that is going to be A is equal to P parentheses 1 plus R over N close parentheses, and that's raised to the power of N T. We're going to talk about what each of these items are. A is equal to the total principal plus interest. In other words, that's the final amount that's going to be in the account at the end of 5 years, or that's going to be the total amount that's been paid at the end of 5 years. P is the principal. That is the initial amount of money that we're talking about. In this case, we're going to be the $1,000. R is the interest rate. N is the number of times interest is applied per time period. So I'm going to use the pound sign for number. Some of you think of that as hashtag. It's also known as the pound sign, and it's also known as number of times interest is applied per time period. And in this case, we're talking about a year is our time period. We're going to have 5 years, but the time period is 1 year because we're multiplying that by 5 is our total time. So it's being compounded monthly. That means there's going to be 12 applications of interest. And what compound interest means is that you get a certain amount of money. It earns interest. That interest is added to the account, and then you earn interest on the principal plus the interest you earned. And that amount is paid. That amount goes into the account, so you then get interest on the principal plus the interest, and on and on. And that's why, in theory, it's going to grow faster. And T is the final amount. That's the time. So based upon what we've been given above, let's talk about what these amount is. The A, that's what we're trying to calculate, the amount of principal and interest. The principal in this case is $1,000. The interest rate is 3%, but we're going to write it as a decimal, And I do have a video on how to convert decimals to percentages and percentages to decimals. So we're going to write that as 0.03. So check out that video that I have showing you how to do that. The number of times interest is applied per time period, and as we discussed, since it's being compounded monthly, the time period is 1 year, and over the course of 1 year, it's going to be applied 12 times, so that a number is going to be 12. And our total time, how many years is it going to be? Well, it's 5. So we've got all the information we need now, and I like the strategy of doing it. I like to write everything out, label everything, and then go to work on it. It makes it a lot simpler. So I'm going to rewrite the formula, but I'm going to use boxes because I like using boxes that are labeled so then we can fill things in. So the first thing we have is the P, which is the principal. And then we have parentheses, and since that number was going to be right next to parentheses, we know that that is like multiplying. We have a 1 plus, and we have an R. This could be a capital R or a small r. Pay attention to how it's written. You're going to want to write it the same way. I'm going to put it as a capital R since that is what I have used above here. But oftentimes you'll see that as a small r. Don't let that throw you off. N divided by N, which is the number of times that the interest is applied. And so we need a box for that, and we need a box for our R. And then I close my parentheses, and I have up here, it's going to be raised to a power, and we have an N here, and we have a T here. So now we have boxes labeled for everything, and we're going to go and fill them in. The principal amount, as we see above, is 1,000. We have our 1. Our rate, our R is 0.03. Our N is 12. I'm going to apply the N up here as well. And our T is time is 5. So all our boxes are filled in, and we can start calculating everything. Now, we have to worry about order of operations. You can get a very different answer if you don't follow the order of operations. And I do have a video showing how to do order of operations, and that is linked above. I'm going to write this a little cleaner. So this is 1,000 times 1 plus 0.03 over 12, parentheses, 12 times 5. Our order of operations, let's take care of this inside first, the inside first. So let's, first of all, before we do any of that, we remember our order of operations is going to be parentheses. So we're going to do this first. So let's go ahead and we have addition and we have division. Let's do the division first because division is a fraction is division. So I'm going to go 0.03 divided by 12. And that gives me 1 over 400. So I'm going to go 1 plus 1 over 400. Close parentheses. I've got 12 times 5 up here, and I've got 1,000 here. And that's still equal to A. I can convert this 1 over 4,000 to a decimal by doing that, but it's it is a little bit unwieldy there. So we can change this 1 into a 400 over 400 because that's the same thing as 1, and add it to 1 over 400. Put my 1,000 here, equal to A. And let's go ahead and multiply this out here. So we have 12 times 5, which is 60. So it's raised to the power of 60. This is an exponent. And we will deal with the exponent before we do anything else, but let's deal with this. So we're going to, now we have 400, because we have a common denominator, that's why I made this 400 over 400. And I show in another video how to add fractions. I have 401 over 400, all raised to the 60th power times 1,000. I can now, and if you want to know about raising things to a power and how to deal with that, I've got some videos on that. This I can go ahead and enter into my calculator. It'll make it a lot simpler, and I'm going to enter it just like it looks. So I have 1,000, and I'm going to multiply it by, and I'm going to put parentheses, and my fraction is going to be 401, and I go down, and my denominator is 400. I move that over, I close my parentheses, and I raise it to the power of 60. So it looks exactly like I have here, and that's going to give me my A when I hit equals. When I hit equals, and that gives me, and it thinks a moment, 1,161.616. And since it's money, I'm going to round, and I do have a video on rounding. So our A is equal to $1,161.62. That's our answer because we round it to pennies. That is if we leave our $1,000 in the account that is compounded monthly for 5 years. Contrast that with, if you recall, when we did that calculation with simple interest, we wound up with an amount of $1,150. So you can see by compounding monthly, we get more money, and that makes sense. I always ask myself, did the answer we get make sense? And in this case, yes, it does make sense. So I hope you found this helpful. If you have any questions or comments, put them down in the comments below, and there's some opportunities to get some Professor Capko merchandise and do some other things that support this channel. Just check out the description here, and keep your grade alive and subscribe. Until next time, this is Professor Capko.